of you students. Students, as you know that in our chapter 3 we learned about ionic bonds, right? So there is one more kind of bond that we have to learn before we go into the chapter 4, that is carbon and its compounds. Let's learn about the other type of bond, and its name is covalent bond. Do you remember, children, ionic bond? What kind of bond is it? It is formed by the transfer of electron. Completely the electron gets transferred from one atom to the other. Why are they combining? As I told you, in order to get stability, they tend to lose or gain electrons, because of which oppositely charged atoms are formed, and there is an electrostatic forces of attraction which holds them together strongly, so that a compound is formed. Unlike ionic bond, in covalent bond there won't be any transfer of electrons. Instead, there will be a sharing of electrons, children, because both the atoms that will be forming an element or a compound, they will be actually in need of electrons. Both of them would require electrons. So the best thing that they do is they share the electrons. You will understand well when I give you some examples. For now, you understand that covalent bond is a type of bond that is formed by the sharing of electrons between the atoms. Here, the atoms which involve in the formation of compounds require electrons. Both of them require electrons, and hence there will be no transfer but sharing of electrons. Usually, these covalent bonds are actually formed between two non-metals, children. So between any two non-metals, you will find if a bond is there, that's nothing but a covalent bond. You know that non-metals usually have 5, 6 or 7 electrons in their outermost shell, so that they would need 3, 2 or 1 electron in order to get the stable electronic configuration. Right, children? So let us see that covalent bond, actually it is of 3 types, children. Single bond, double bond and triple bond, based on the number of electrons that are shared. Okay, if only 1 electron is shared between 2 atomic species, then it results in the formation of a single bond. If 2 electrons are shared, it results in the formation of a double bond, and if 3 electrons are shared, it results in the formation of a triple bond, children. We'll see some examples over here. Exception: hydrogen atom, as you know that it has got only 1 electron in its shell. So this 1 electron, in order to this hydrogen atom, in order to get stability, it should gain actually 1 electron. But you know, if you see that when 2 hydrogen atoms are actually involved in binding in chemical combination, then you see that both of them would require electron. No one can give away the electron, because they will be left with none, left with any, right? So both of them require this electron. What they do, instead of transfer, they will be sharing the electrons here, such that this hydrogen gets both and the other hydrogen atom also gets both the electrons. They will be sharing the electrons, hence a bond is formed. Can you see? A bond is represented by a single line like this. So if it is a single line, it means that only 1 electron is shared, and that means only 1 pair of electron is shared between the 2 atoms. So it's just like, you know, I'll give you a simple example, children. Think that you have first half of one textbook, and the other person has part 2 of the textbook, part 1 and part 2 of some textbook. Okay. Now, in order to prepare for the examinations, you need both the books. What will you do? You can't give away to the other person, because you will be left with none, right? So what you do? You share the books, right? You first learn both the books will be shared between you both. In the similar manner, this happens in case of covalent bond, children. Instead of transferring of electrons, there will be sharing of electrons. You see that always it's not the case that only same kind of atoms combine. There can be formation of compounds also, like this. You can see hydrogen and chlorine. Hydrogen is like, it acts as a metal and a non-metal as well. But chlorine is a non-metal, right? So both of them share electrons. Hydrogen has one electron in its outermost shell, and the electron dot representation of chlorine is in this way because the electronic configuration is 2, 8, 7. Right, children? So there are 7 electrons present in the outermost shell over here, like this. 1, 2, 3, 4, 5, 6 and 1, 7. How many electrons now the chlorine needs in order to get stability? If it gets 1, it gets the nearest inert gas stable configuration, right? So, instead of taking away the electron from hydrogen, because hydrogen also needs this, so there will be a sharing between them. How many pairs of electrons are getting shared here? 1 pair only. See here now, this hydrogen has 2 now. And this chlorine has how many count? 8, right? So both of them achieve the stable electronic configuration by sharing. So that is how a single bond is formed between atoms. Did you understand, children? Coming to the double bond, you should now, by now you should have understood that here how many pairs of electrons are shared. 2 pairs of electrons will be shared here, children. How? Let's see an example. Oxygen electrons in the outermost shell, children. So, oxygen is undoubtedly a non-metal, right? So, 6 electrons are there in the outermost shell. How many should it get in order to get stability? 2 more. So, here what they do is, they share two pairs of electrons now. Can you see? Such that each one will get 8 electrons in this outermost shell. This oxygen is getting 8 electrons and this oxygen is also getting 8 electrons now, so that both of them achieve the stable configuration. So that's now you can see that how many pairs are actually forming the bonds? 1 pair and 2 pairs. So that's why it is represented by a double bond between 2 oxygen atoms. Always remember, oxygen atoms pair by a double bond. Okay. Because they require 2 electrons. Here hydrogen requires 1 electron only. HCl also both require each 1 electron only. But here oxygen requires 2 electrons. So 2 pairs of electrons will be shared among the 2 oxygen atoms. There is triple bond also. How is it formed now? Now if you take a look at, if you see nitrogen here, what is electronic configuration of nitrogen, children? 2, 5. That means how many electrons does it need in order to achieve the stable electronic configuration? It requires 3, such that it becomes 2, 8. So the other nitrogen atom also requires 3. So what happens? There will be a sharing of 3 pairs of electrons. Can you see here? 3 electrons will be shared among these 2, such that the compound is held by 3 bonds now. And that's nothing but called as a triple bond. So this is about covalent bond. I want you to just note down these examples in your rough book, practice how the bond is formed and you compare. Last time I sent you one small handout like pics actually showing the difference between ionic and covalent compounds. Please go through it, and next week we shall be starting a new chapter, children. Okay? Thank you.